All right, so beginning our last simple solid. Do you guys remember how we had this relationship between cylinders and cones? Cylinders had circle-shaped bases, so did cones. To find the volume of a cylinder, we did pi r squared times the height. The volume for a cone was 1/3 pi r squared times the height. So it was 1/3 the volume of the cylinder. And then we had a similar relationship on the surface area formulas too. We're going to look, we have the same types of relationships between prisms and pyramids that we did between cylinders and cones. So I want to talk about the parts of a pyramid, and then we'll talk about the two types of pyramids, right pyramids and oblique pyramids. So up at the tippy top, we call that the vertex. Going from the vertex right down to the center of the base is the altitude. This is the height of the pyramid, and it's perpendicular to the base. Right down here, pointing at this line. That is a base edge. This is a base edge. This is the base. And then over here on the left, we are pointing to this edge right here. This is a lateral edge. And this triangle right here is a lateral face. The lateral faces are all triangles. The base of each of these triangles touches the base of the pyramid, and the vertex of the triangles form the vertex of the pyramid. The lateral edges are where the triangles touch each other, and the base edges are where the triangles touch the base. Right. So with a right pyramid, let's talk about a right pyramid first. In a right pyramid, the altitude meets the base at the base's center. So I'm going to go ahead and draw in the altitude here. Here's the altitude. Makes a right angle where it hits the base. This right here, going down one of my lateral faces, is the slant height. Which again, we use cursive L to mean slant height. This is the height of the triangular lateral face. So the slant height of the pyramid is the height of the triangle. And now oblique pyramids. With oblique pyramids, these we are just going to define as non-right pyramids. An oblique pyramid is one that does not meet the requirements to be called a right pyramid. So looking at some formulas now. We know that to find the volume of a prism, that is area of the base times the height. The volume formula for a pyramid is related to that. It is 1/3 area of the base times the height. Again, the capital B is area of the base. H is height of the pyramid, the altitude. One-third area of the base times the height. So exactly what we were doing with our prisms, we will do the exact same thing for pyramids. We will just have the 1/3 in front. Surface area, if you look, I have taken this pyramid and deconstructed it, laid it open flat. It is made up of one base and a set of triangles. The number of triangles is equal to the number of sides on the base. To find the surface area, we have just our one base, so 1b, plus half the perimeter times the slant height. This part right here is the lateral area, which is what LA means. When we say lateral area, what we mean is the total area of all the lateral faces. And the lateral area is 1/2 perimeter times slant height. All right. We are going to try some problems now, so if you do not have a yellow calculator, please go and get one. If you do not have a yellow calculator, please go and get one. Let's try a problem. We want to find the volume and the surface area for a right square pyramid. This part right here is telling me the shape of the base. says we have a base edge of 12 feet and a height of 8 feet. So it tells me the base is a square. That's what the right square pyramid means. So all 4 sides of the base are congruent. And how big is each side? 12 feet. So we're going to add that to our picture. And then it also says we have a height of 8 feet. So from the vertex of the pyramid straight down to the base, and it hits the base in the center, makes a right angle where it hits the base. That is 8 feet. All right, and we want volume and surface area. Volume is 1/3 area of the base times the height. Well, the area of the base, what shape is the base again? A square. How do you find the area of a square? Side squared. How big are our sides? 12. So we take 12 and we square it. What is 12 squared? 144. So 144 feet squared for the area of the base. So I have volume equals 1/3 times 144 times the height of the pyramid, which is 8. And then we take that and substitute it into our calculators. Plug it into the calculator. Yep, 384. That would be feet cubed. All right. Then surface area. For surface area, we have just one base, so we need just the area of the base once, plus 1/2 the perimeter of the base times the slant height. Well, I already have the area of the base. That was 144. Plus 1/2. Then we need the perimeter of the base. All the sides of the base are how big? 12 feet. And we have how many of them? 4. So number of sides times the length of each side. 4 sides. Each side is 12. What is our perimeter? 48 feet. So here we have 48. And now we need our slant height. To find the slant height, I'm going to bring the height over to one of my lateral faces. That's going to be the distance from the center of the square to the edge of the square. If this is the exact center of the square, how far would it be to go over to one of the edges? 6 feet, exactly half of my base edge. So this would be 6 feet. Kind of like a radius, except we got to be really careful because if my base is a different shape, is not a square, then what I'm looking for is the apothem. With a square, we can take the base edge and just cut it in half because a square has some very special properties to it. But if the base is any other shape, then we need the apothem there. But you could think of it kind of like a radius-ish. And we have our slant height right here. So I'm going to redraw that triangle just so that I can see all my pieces. We have the height, which is 8 feet. We have what's basically the apothem here, which is 6 feet. And then we have our slant height. The height, the 8 feet, and the base form a right angle with each other. So what can I use to find the slant height? Pythagorean theorem is absolutely correct. So we've got a squared plus b squared equals c squared. Which part of that has to go in for c? Slant height. And what do we have that represents slant height? The cursive L, yes. So we have cursive L for slant height that I'm going to put in the place of C. What goes in for A and for B? 8 and 6. One goes in for one. The other one goes in for the other one. Order does not matter. It does not matter which one is the 8 and which one is the 6. So I have 8 squared plus 6 squared equals L squared. 8 squared is 64. 6 squared is 36. What do we get when we add 64 and 36 together? 100 is equal to slant height squared. Then we're going to take a square root of both sides. Over on the right, the squared and the square root cancel out. What is the square root of 100? So 10 feet is my slant height. That's what we're going to use over here in place of the cursive L. So for my surface area, we have the base area of 144 plus the lateral area. What is 1/2 times 48 times 10? 240. And so then we add 144 and 240 together. That gives us 384 feet squared. Now, this one's kind of interesting. What was our volume? 384, and our surface area came out to 384. Does that normally happen? No, but does it mean that we made a mistake? No. We did this process correctly. Sometimes, every now and then, the volume and the surface area will come out to be the same, but with different units, because volume is cubed and area is squared units. I want you guys to flip the page and look at number 2. I'm going to give you, let's take about 3 or 4 minutes. I want you to do number 2 on your own. I'm going to leave the work for number 1 up so you have that to look at to guide you as you do number 2. If you get stuck on number 2, please let me know. Mark up the diagram as you are trying to figure this out. If you get stuck on any pieces of it, please let me know. I'm happy to offer assistance. You're right. Okay, well, mark up your picture.
Is it the same thing as height?
No, slant height is not the same thing as the height. Slant height goes along a lateral face, so along one of the triangles. The height is right here, exactly where you put it. The slant height is here, along that triangle. You get it? Okay. You're welcome. Yes. Where's the slant height in the picture? So, no, that's not the slant height. Look at where we have it up there. It's in pink on the picture. It's not running along a lateral edge. What you pointed out was a lateral edge. Where the two triangles meet is a lateral edge. That's not my slant height. Slant height runs down the face of the triangle. It goes from the vertex to the edge, straight down the center of that triangle. I'll be right there. Okay, so let's start here. That's not your slant height. That's a lateral edge. The slant height runs down the face of the triangle, not along the edge there. Let me go get an actual model to show you. So these are not the same sizes. That's why we have to do this one and not this. So again, you still have to point into a lateral edge. It comes down the face like in this. The height you have to draw correct. The height would be that if I do a whole this vertex right down to the bottom. That's the height. This is the slant height. All right, I know that we have several people with more questions. I'm going to go ahead and start going through this because it looks like we're all stuck at about the same spot, which is fine. What did they not give us this time that we had on the last one? We had the base edge. This time they didn't give us the base edge. What did they give us instead, though? They gave us the height and the slant height, yes. Our height is 15 meters. That goes from the vertex straight down to the base, and when it hits the base, it makes a right angle, and that is 15. The slant height goes down a lateral face, so it's going to go down one of the triangular faces, right down the center of the triangle, not one of the lateral edges, but right down the center of the triangle like this. That is our slant height of 17. That is this piece here. To find the volume is 1/3 area of the base times the height. So we need to find our base edge if we're going to do that. Well, if I'm going to find the base edge, this much right here would be half my base edge. So I'm going to call this X. If I call that X, then this right here would be 2X. And this side over here would also be 2X because it's a square. It tells us that it is a right square pyramid. So looking inside my pyramid at that triangle that we have drawn, looks like this. I know this much is 15 here. And I know this is 17 here. Remember, the height makes a right angle where it hits the base. What could I use to find what we're calling x? Pythagorean theorem is absolutely correct. All right, so we have a squared plus b squared equals c squared. What has to go in for c? Be careful here. 17. The slant height goes in for c. C is not just whatever you're looking for. Some people are getting in the habit of putting in the two numbers for A and B. That is not always correct. You have to make sure that it's the hypotenuse that is going in for C. Otherwise, it gives you a very wrong answer. All right, so then 15 goes in for either A or B, and X goes in for the other one. So I have 15 squared plus X squared. So that would be 225 plus x squared equals 289. Subtract 225 from both sides. We get 64. Let me catch up to you real quick. X squared equals 64. Now what do? Square root. If you do it to one side, got to do it to the other side. The squared and square root cancel each other out over on the left. We get x equals 8. So that is half of a base edge. So if that is 8, I'm going to replace it in my picture with an 8. How big is the base edge? 16. Now that we know how big the base edge is, can we find the area of the base? Yes. Area of the base, big capital B, is equal to side squared. Yep. So we would have 8 squared, which would be 64. 64 meters. Oh, 16 squared. Thank you. I grabbed the wrong number. Thank you so much for correcting me. 16 squared. Because it's the whole base edge, not that half base edge. Thank you so much for catching me there. What is 16 squared? 256. All right, so now we can come and use our volume formula. Volume is equal to 1/3 times 256 times what? Is it 15 or 17? What do we use for H? 15. It says the height is 15 meters. Remember, that's the same thing as the altitude. All right, so then we grab our calculators. 1/3 times 256 times 15 gives us what? What did you say? 1,280, and that would be meters cubed. All right. Then we have our surface area formula. Surface area is area of the base plus 1/2 perimeter of the base times the slant height. So we know the area of the base, that's 256, plus 1/2. Now we need the perimeter of the base. The perimeter of the base is a square, so it's number of sides times the length of each side. How many sides do we have on our base? 4. How big is each side? 16. What is 4 times 16? 64. So that would be 64 meters for our perimeter. So that's what we're going to put in for P. Times our slant height. What was our slant height? 17. I need to scoot all this over just a little bit. Hold on. Not quite enough room to input my 17. There's a 17. All right, so surface area is equal to 256 plus what? What is 1/2 times 64 times 17? 544. And then we add those two together and we get what for our total surface area? 800 meters squared is absolutely correct. All right. So that is pyramids with square bases. On Monday, we will finish up pyramids and we will do an example where we have a pyramid with a non-square base so that you can practice doing that. We will also practice a problem where they give us either volume or surface area and we are looking for either height or slant height or base edge. The homework that you picked up on your way in the door will be due on Tuesday. Homework is due on Tuesday.